Okay, this is 8.5 video for variation of functions. Okay, so we will notice that we have a lot of vocabulary. Basically, our objectives are we're going to do four kinds of variations. We're going to recognize and solve both the direct and joint variation problems and then inverse and combined variation problems. So the first thing is let's go straight to our definitions, and here we are. The first one is direct variation. So direct variation is just a relationship that can be expressed in the form of y equals kx. And it's a special case, so we said y equals kx, and it's a special case of the slope-intercept form, y equals mx plus b, where m is equal to k, which is the slope, and b is equal to 0. So you always have it going through the origin. So b is always equal 0. Okay, now we call k the constant of variation, which is our second vocabulary word that we have, is our constant of variation. And that is going to be k. Basically, it's your slope. It's a way to think of it. Nothing much to it. So, basically, it's a straight line. So, to express direct variation, we say that y, the dependent varies directly as x. In other words, as x increases, y increases. As x decreases, y decreases at some constant rate. So here's our key concepts. We say y varies directly as x. If there is some non-zero constant k such that y equals kx, k is called the constant variation. So what does that mean? So first of all, it's proportional. It's just a slope, slope and b is 0. It's just a linear equation. So if we have two sets of data, and we call it y1 and x1, two sets of coordinates, and we say y1 equals k times x1, our formula, and then y2 equals kx2. And we solve for k in both of them. We get y1 over x1 for the first one and y2 over k2 or x2. Then we can substitute k and set them equal to each other, and we have a proportion. So there's different ways of solving this. We can solve it proportionally or finding k and using our equation. So we can say y1 over x1 is equal to y2 over k2. So it's important to know that they're proportion. Now let's go directly into example 1. Okay, so example 1 tells us if y varies directly as x and y equals 15 when x equals negative 5, find y when x equals 7. Okay, so we can use our proportion. So we said our proportion is going to be, remember, y1 over x1 equal y2 over x2. So they tell us y varies directly as x. Okay, so it's y equals kx. So we can use this proportion. So we first need to identify x1 and y1. So they tell us y1 is 15. And they tell us x1 is negative 5. They want us to find y2 when x2 is 7. So we first had to identify which one was 1, and it does not matter. Just like in slope, as long as we have the groups together. So the first group was x equal negative 5 and y equals 15. The second group, well, y was unknown and x was equal to 7. So I just made, because I went from left to right, made that 1 and these the 2's, put them in the proportion, and I'm going to do 15 times 7 equal negative 5 times y2 sub 2. We divide by negative 5, divide by negative 5, and we get y2 equals negative 21. Don't forget how to solve equations. That's the easy way to do it, one way. The other way to do it is use this formula here. We take this and we say 15 equals k times negative 5. I solve for k, and I get k equals negative 3. So I put that back in my formula just like I would if I was doing slope-intercept formula. Now I'm going to put in what I know here. I know x, so y equals negative 3 times 7, and I get y equals negative 21. So if I don't want to remember the proportion, I can always do it this way. So this is method 1, book shows you, and then I showed you method 2. Okay. All right, so let's look at joint variation. Joint variation is our second vocabulary. It's just another type of variation when one quantity varies directly as the product of two or more. So basically, it varies with the product of two or more quantities instead of just y varies with x. We might say y varies with x and z, which means the product of x and z. So here, we're going to say y equals k, which is still your slope, x times z. Again, we put those in the formulas and as two different sets of points, and we find k, we solve for k, and we set them equal to each other, and this is our proportion. We are left with the proportion of y1 over x1 z1 equals y2 over x2 z2. So remember, your formula was y equals k x z, the product, because it varies directly jointly with two things. So let's look at example 2, which says, suppose y varies jointly as x and z, which means the product. Find y when x equal 9 and z equal 2 if y equals 20. So they tell us find y, okay, when x is 9 and z equals 2 and and y equals 20 when z equals 3 and x equal 5. Okay, so does it matter which ones are 1s or 2s? No, it doesn't. You just decide what you want to use. Let me find some prettier blues. Not finding them. Okay, so we can call these the 1s and these the 2s. We said we can use either method here. Okay, our formula is y equals k x times z. So we can use a proportion, which was y1 over x1 z1 equal y2 over x2. And these proportions are just grabbed using algebra. We're just solving. So we don't know what y1 is, and 9 times 2 equals 20 over 3 times 5. I could have switched them. These could have been the 2s and these could have been 1. So now I just cross multiply and I get 15 y1 equals 9 times 2 times 20. Divide by 15, divide by 15, I get 1y equals, so divide by 5, I get 3, I get 4, I get 1, I get 3, and I get 3 times 4 is 12. So y1, or y2, whichever one you want to call it, equals 24, or the unknown. Okay, that's it. So direct, y varies directly with x, which is y equals k, the slope, times x. And if you have joint, that means you have more than one. That's all. Now, we're going to learn inverse variation. So in direct, if you got a graph, as x increases, so does y. The slope is positive. Okay, as x decreases, so does y. All right, now let's look at inverse. It's quite the opposite, and these are usually used in real-world problems. So that was joint. So we're going to move on to inverse. So inverse is just another type of variation. If you have two quantities, x and y, we say their product is equal to the constant. So inverse variation is called as one quantity increases, the other quantity decreases. Okay? For example, speed and time for a fixed distance varies inversely with each other. The faster you go, the less time it takes to get there. So y varies inversely as x if there's some non-zero constant, k again, such that y times x equal k, or remember we're doing functions when we're graphing, we always solve for y, and so really the function is y equals k over x. So the function is really y equals k over x. But when they solve for k, we get here, now we get the product of y and x. Whereas direct variation, it was the quotient of y and x. Okay? So if x times y equals 2, which is your k, and x is 6, you put in a formula and you get y equals 2, 6, or 1/3. So let's look at this. Suppose y varies inversely as x such that x, y equals 6, or y equals 6 over x. What do you notice about this graph? So we said y equals 6. We can rewrite it to say this, right? We have a what? Reciprocal function. We just got through learning how to graph those. Remember, they're hyperbolas. All right, so the graph is shown at the right, and since k is a positive value, as the x values increase, what's happening to y? It's decreasing. You can notice it here too. And it is an inverse variation, is a reciprocal function. Again, we can have a proportion. So we take the 2, x times y1 equals k, x2 times y2 equals k. So inverse relations are this right here. And this is what they're showing you in the book. All I did was use algebra to move this x over and get from here to here, okay, or back and forth. So we get, if we have two values, so we get this, so we can say y1 times x1 equals y2 times x2, and then we solve for y, we get y1 over x2 equal y2 over x1. And I just use algebra to take this formula and transform it to this. All right, so this is our proportion if we want to memorize it, or we can memorize this. They work both ways, two different methods. So let's look at an example of an inverse variation. So it says in the example here, 3, if A varies inversely as B, so A is your y and B is your x. A is 28, B is -2. Find A when B is -10. So I'm just going to first write them out. So they told me A equals 28, B equals -2. They want us to find A when B equals -10. So what is our proportion? So it's going to be A1 over B2 equals A2 over B1. They're just crossed. These are inverse. Okay, so remember, we can look at this as the y and this is the x. All right, so now I'm going to call these my 1s and these my 2s, and I'm going to put them in my nice little formula that I have. So I'm going to have 28 over -10 equals A2, because that's what my unknown, over -2. And then I'm just going to cross multiply, and I'm going to get -2 times 28 equals to -10 times A2. In case you wonder what cross multiplication, I'm doing the butterfly method. When two ratios, right, two fractions are equal to each other proportion, and we say the product of the cross are equal to each other, and that's how I just use algebra to solve. And then when you solve this, you get A2 equals 5.6. All right. So let's now look at example 4, where they want us to write, because a lot of times inverse are used in real world equations. So or problems. So they tell you the length of violin string varies inversely as the frequency of its vibration. So I know that you can call it whatever letter. L varies directly or inversely as its frequency. Okay, so you can call it, let's just call it V to make it better. Violin varies inversely as a frequency. So remember, this one is your dependent, this is your independent, this is your formula. So now let's go to see what they tell us. They said a violin string 10 inches long, so we're going to say V equals 10, vibrates at a frequency of 512 cycles per second. Find frequency, so they want us to find F if it has an 8-inch violin string. So V equals 8. Well, what was our proportion here? Remember, I can do it two ways. I can just use a formula and say, we can use proportions, or you can use this formula, V1 times F1 equals V2 times F2, right? Because K is the same for both of them, we know. So now I just call this 1, 1, 2, 2, and I get 10 times 512 equals 8 times F2, and I use algebra to solve, and I get F2 equals 640. So remember, your proportion is also going to be what? V1 over F2 equals V2 over F1. We could have used this just as well because they're proportional. So I don't know this, and I know this is 8, this is 512. Okay, so 8 F2 equals 10 times 512 when I did the butterfly method. And you see I got the same thing. I did just flipped using symmetrical properties. So I'm going to get the same value. All right, so that is inverse, right? Y equals K over X. And direct was Y equals K times X. And then we're just using this to solve for K to get our proportions of Y and X. All right, so now the next part of this is called combined variation, which is just another type of variation. Basically, this says you have both a direct and a inverse variation as one. So basically, you can say when one quantity varies directly and or inversely as two or more quantities. All right, so if you know y1 equals k, so what they use here is they say y varies directly as x and inversely as z. Okay, so then they did another set and do the same thing. Okay, x2, z2. So now I can say y using algebra, I solve for k, I get y1 times z1 over x1 is equal to y2 times z2 over x2. So you see y varies directly as x and inversely as z is how it's read. Or it can say y varies directly as x and y varies inversely as z. We just combine them as one problem. So let's look at example 5. It tells us, suppose f varies directly as g and f varies inversely as h. So they're saying f varies directly as, you always have k, as g, and inversely as h. Okay, so there's our equation. Find g Now we come and write down what we know. When f equals 18 and h equals, I thought that was negative 3, yes, if they tell us g equals, so they have to give us all of one of them. G equals 24, h equals 2, and f equals 6. So again, does it matter which ones are our ones? No. We had to set the equation up. Now we're going to do our, remember our proportion is going to be F1 over G1 times H1 equals, and I just use the algebra. You have to go in algebraically solve for K. H2 over G2. So I'm going to put that in here. So I know 18 times negative 3 over G1 equals 6 times 2 over 24. So I've set up my proportions. Now I just solve. How do I solve it? I take the product of this equals the product of this. So we have 12 G1 equals 18 times negative 3 times 24, and divide by 12, and I get G1 equals, and I'm going to reduce, and when you multiply all this out, you get negative 108. Okay, so it's just putting numbers in using linear equations, all right, and reciprocal functions. So the inverse is a reciprocal function, and the direct variation is just a slope-intercept function with b equals 0. All right, do the homework problems, and we will see you in class.